Good evening. Welcome to the QCIS channel. Well, on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening I'm going to talk about sustainable construction. Now, generally, when we deal with sustainability, we're talking about making a society healthy for we human beings to live in. And sustainability goes with energy. Now, if you really think about it, sustainable building is a subset of sustainable development. Now, when we deal with the building, however, we're talking about types of materials that are energy efficient. Let me give you an example. Harvest wood. Now, some buildings take wood that was from an old barn. They call it harvest wood. They recycle it and it can use that wood for material. They can do the same thing with bamboo. And there are other materials out there as well. Now, sustainability also involves, I call them sensor switches. When you go out of the room, your lights automatically go out. You have the same thing when it comes to your toilets and your fixtures. Again, we're dealing with energy. We're also dealing with things like LEED. And when we talk about LEED, we talk about leadership, energy, environmental design, and a number of your buildings out there are LEED compliant. You have a point system when we deal with LEED. Basically, you need about 30 points to become LEED certified. If you are an employee or a manager, you can become a LEED associate. You can be an engineer and have LEED. But when we deal with sustainability, we're dealing with how we can make buildings operate using the environment and making the environment better. And that's by reducing carbon emissions, reducing pollution. Now, I know you hear all this talk about electric cars. For the most part, I like hybrid cars because they're both. You hear about solar power, wind power. I mean, those are renewable energy sources. Something else, power plants, nuclear power plants over in France. Nuclear power is clean. A lot of people here, they're against it. Although we have a number of nuclear power plants here. I lived in Pennsylvania. There are 5 nuclear power plants. But again, this video is about sustainable building. And when we really deal with sustainable building, we're talking about green energy or green alternatives. Now, some green alternatives may not cost you a lot of money. Let's give you an example. If you have a street, you can plant trees. Trees are good for keeping the sun away from windows. Might not want all that heat, but also that sun can be a source of heat in the wintertime. Yes, you still have to run your furnace, but you may not have to run it as much. And part of green alternatives are where you're going to build your buildings. If you look at a number of buildings in these cities, they have a lot of glass windows. You look at some of the floors. I'll tell you a place you can go and look at an energy efficient building. Go into some of your Walmarts or in your Aldi's. Well, it used to be when you went into your grocery stores, you would see the ceiling and it would have what we call the drop ceiling panels. You don't see those anymore. They've eliminated those for the most part. Now you can see the pans that they put up there, the joist that they put up there. Well, all that is for energy efficiency. Now, I want to get into a short PowerPoint, and I'm presenting this, but this was presented also by a gentleman, and I have to give him credit, by the name of Haven Alford. Now he talks about sustainable buildings and green markets. And he utilizes the engineering perspective. Now the overview, why does it matter? Talk about elements of sustainable buildings, government application, which are green market initiatives. So when we deal with the environmental impacts of buildings, why does it matter? Well, from the US Commercial Building Facts, 65.2% of total US electricity or consumption. 65.2 total US electricity consumption was greater than 36% of total US primary use. And then we have 30% total US greenhouse gas emissions, 136 million tons of US construction demolition waste, about 2.8 pounds per person per day. Then we have 12% of potable water in the United States, and 40%, which is 3 billion tons of raw materials used globally. That's why it matters. This is where you get your environmental impact of buildings. Now, 5 broad areas of applications. Well, we have sustainable sites, energy and atmosphere, indoor environmental quality, water efficiency, resources and materials. Now, when we talk about sustainable sites, we're talking about areas that are, they could be right around wetland areas. It could be also be an area that has a green building on that site. And you might want to put another green building on that site. When something is sustainable, clean water on that site too, to make everything sustainable. You want to have a sustainable site, you use your best management practices, like using stone for your construction entrances, making sure that you clean off the existing road of all debris when you're going in and out of the construction site, setting up retention ponds, setting up silt socks, utilizing inlet protection, silt fences. That's how you make your site sustainable. In other words, you want to keep sedimentation from getting into your water source. And we have energy and atmosphere. Well, you want to make sure that the ozone layer isn't destroyed. It used to be when you sprayed aerosols, which came from deodorants. Well, too much aerosol sprayed in the air could ruin the atmosphere. And when we deal with energy, we could be dealing with solar energy. We could be dealing with wind energy. Then you have indoor environmental quality, a water efficiency. materials. Again, bamboo, harvested wood. Now, I talked about momentarily LEED, the LEED concept and intent. Now, LEED is the standard for sustainable design on a worldwide basis. So basically with LEED, design and construction practices that significantly reduce or eliminate the negative impacts of buildings on the environment. Then when we actually break it down and get into LEED, LEED has different rankings. So basically LEED is a point system that ranks the sustainability of a building design by being, it's either certified, you need 26 to 32 points. For silver, you need 33 to 38 points. Gold, 39 to 51 points. And the top is platinum, 52 to 69 points. Now, why engineers should care and why you should care? Well, this is how we look at LEED. Okay, the discipline. We have 28 points, which is 41%. Architecture, landscape architecture, 21 points, 30%. Civil engineering, 11 points, 16%. Constructor, 4 points, 6%. Undefined, 5 points, 7%. All totals 100%. So you add all those scores up, you get 69 points. If you think about it, that's platinum when we deal with LEED. Now, let's go into sustainable sites again. Well, basically, I gave you my overall view of what a sustainable site is or how you can make it sustainable. Well, when we deal with sustainable site, we talk about the density development, the site selection, the brownfield redevelopment, and then we talk about alternative means of transportation, like bicycles, public transportation, parking capacity, and then we talk about alternative fuel vehicles, like electric cars, hybrid cars. Really want to get into some alternative vehicles. They now have electric bicycles and scooters in so many metropolitan areas. You want your site disturbance to be reduced, and you want to have good storm water management. Now, when we deal with vehicles, we're talking about alternative fuel vehicles. I just mentioned electric vehicles. See a number of electrical charge sites that are going in. Now, I still like gas powered cars, but my favorite would be the hybrid because it's a mixture of gas powered and electrical. And the more of those cars they have, the really those are efficient. And this is just personal for me because with an electric car, how often are you going to have to charge your car? With gas, there are times where you're going to have to stop and get gas as well. But if you have a mixture of both, it will save you time and money when you travel. Particularly these days, gas and electric are expensive. So if you can reduce the usage by having a hybrid car, that's going to save you some money. And it's going to keep you continuing on your trip. Because again, when you go on long trips and you have to fuel up, it costs a lot of money, especially when you're paying $3, $4, $5 a gallon for gasoline. Now, again, going back to sustainable sites, talk about reduce site disturbance. Well, we're going to protect and restore our open spaces. We're We're going to have a footprint for development. And then stormwater management. We're going to deal with quantity and rate, and of course, treatment. And then we have the heat island effect. And this is when we deal with buildings that have roofs and buildings that have no roofs. And then we deal with light pollution reduction. This is what you call a green roof. You have your vegetation growing right on top of your roof right here. Also, this roof right here shields you from the sun as well. And this is real growth coming out of that roof. And also with sustainability in the green, it's also aesthetically appealing because you can take a roof that didn't look great and actually put a garden on top of it. Something else that's pretty green, growing your own food. And I'm not talking about GMOs. Because if you know how to grow your own vegetables, that's less trips you have to take to the grocery store. And it's also less money you have to pay. But you have to remember, you have to actually have the sun in place to grow anything. And you have to have water to keep the moisture so your plants will grow. Light pollution. You have a lot of lighting all across the United States, particularly in your urban areas. You look at lights now, they're using liquid electrical display lights. Used to be they had those, they were kind of, I would say gold. Those are lights with sodium in it, very bright. But they had sodium, and I believe they were expensive. You can still see some sodium lights out there, but a number of lighting you see is going to LED. Water efficiency. Well, you want to have your landscaping, but you want to reduce your efficient landscaping by 50%. That means no potable use or no irrigation. You have a water use reduction of 20 to 30%, and then you can find innovative wastewater technologies. And that's innovative wastewater technologies. Something that I haven't seen, but you now have waterless urinals and compositing waterless toilets. Now that's something very different because you generally need water, especially if you're going to flush the waste down. Now they have something that's going to take the, it's going to suck it down using some type of pneumatics or air, but how do you get that pungent smell out? See, these are alternative innovations. Now, right here, this is a waterless urinal and a waterless toilet. I've never seen one of those. It's interesting. All right, energy and atmosphere. Well, under energy and atmosphere, you have to have fundamental building system commissioning. Basically, when you commission a building, you're getting it ready for operation. And you have minimum energy performance, CFC reduction in HVAC and R equipment. Now, what does HVAC and R stand for? It stands for heating, ventilation, air conditioning, and refrigeration. Then with energy and atmosphere, you optimize energy performance. You have a 5 to 10% use of renewable energy. And there's ozone protection, just as I mentioned, green power, additional commissioning, and measurement and verification. Now, here's an example of natural ventilation. Well, you have your windows open. Your ventilation stacks use wind to pull air through a classroom. So the wind is natural. That's why they call it natural ventilation. And then your dampers open. And when you have your natural ventilation, you don't have to utilize any electricity. Now, again, you're going to have wind in order for this type of system to work. If you are in an area where it's very humid and you have no wind, it's not going to work. And we have to be careful as well when we talk about renewable energy, because I know we were on this kick to have windmills. Well, if you don't have wind, your windmill is not going to work. And speaking of renewable energy, wind power. A lot of states going to wind power. Then you have photovoltaic roof systems, which basically solar systems. Well, if there's no sun, these panels don't work. Now, if you look at these panels that are put up, they're probably about a 45-degree tilt. Generally, you want more sun because the sun is closer to the earth in the summertime, whereas in the wintertime, the earth tilts a different way. It's closer to the sun in the southern hemisphere and farther from the sun in the northern hemisphere. I live in the northern hemisphere, and right now we're closer to the sun. This is when you get your tilted axis. Now, when the autumnal equinox comes, the earth is going to be straight up. This is where you get the 12-hour days and 12-hour nights. And then when the wintertime comes, we're going to be farther away from the sun. That's why the seasons are flip-flop when it comes to the hemispheres. All right, materials and resources. Well, you have storage and collection of recyclables, building reuse, maintaining 75 to 100% of existing walls, floor, and roof. Also maintain 100% of the shell slash infrastructure or the shell slash structure within the infrastructure, and 50% of the non-shell, non-structure. Then we have construction waste management. Construction waste management. And that's where we have a diversion of 50 to 75% from a landfill. And you have to be careful because landfills too, it's a lot of trash. Now, one thing that you can do with some of these materials, and a good idea, I know Covada, which is in Virginia, they actually take trash and they burn it and they convert it into electricity because they run their plant off of recycled trash. And that right there, you burn all your trash, you incinerate it, you can have a clean environment that way as well. Resource use, 5 to 10% of materials used are salvaged, refurbished, or reused materials, products, and furnishings, like harvested wood. Again, recycled content, 5 to 10% post-consumer plus 1/2 post-industrial. Then you have regional materials, 20% manufactured regionally, 50% extracted regionally. Then we get into rapidly renewable materials and certified wood. Harvest wood is certified wood. And this is what it looks like. Recycled and rapidly renewable materials. And this wood came from other buildings. Indoor environmental quality. Well, you have a minimum IAQ, which is indoor air quality performance. Then you have environmental tobacco smoke control, carbon dioxide monitoring, ventilation effectiveness, and then you have a construction indoor air quality management plan before construction and before occupancy. Again, let me make a correction here. The before occupancy is correct. It's not before construction. You have your construction IAQ plan during construction. And during construction is before occupancy. Don't want to give you any misinformation here. Also, we have what we call low emitting materials like adhesives and sealants, paints and coatings, composite wood. And then we have indoor chemical and pollutant source control, which is basically controllability of systems, perimeter and non-perimeter spaces. Thermal comfort, compliance with ASHRAE 55. ASHRAE is another, I believe it's the Association of, forgot what the S stood for, but I know it's the Heating, Refrigeration, and Air Conditioning Engineers. It's probably the American Society of Heating, Refrigeration, Air Conditioning Engineers. A lot of people who have HVAC, they're probably in that organization. Also under thermal comfort, you have a permanent monitoring system. Then we deal with daylight and views. We have daylighting in 75% of spaces, which also contains views for 90% of spaces. So daylighting is 75% of spaces, and your views are 90% of spaces. Again, we're getting into energy management. It's a good field to go into as well. Example, daylighting. And just like I was talking about, you have your diffuser, your reflector, your aluminized mylar, work surface, light shelf, specular surface, which also has aluminized mylar, high summer sun, low winter sun, and of course, light shelf. This is an example of daylighting, and architects use this when they're designing buildings, because when you get into the MEP part, you have what we call heat, loss, and gain. And generally, when you have a house, you have a lot of heat loss when you have more windows. Now, the windows are good. You have a lot of heat gain if your house in the summertime faces the sun. But that's detrimental because you want it cool. Now, generally, you have awnings, shutters. You want to reduce heat when it's warm, add heat when it's cold. So right here, you're giving an example of daylight. Right now, I'm just giving you an overview of sustainable construction. Then we have federal government lead applications. And under the federal government lead applications, we have the United States Air Force, the U.S. Army Corps of Engineers, GSA, which is the General Services Administration, Department of State, DOE, which is the Department of Energy, the EPA, which is the Environmental Protection Agency, and the United States Navy. Now, state government lead applications, California, Pennsylvania, on all new construction, tax credit in Oregon, New York, Maryland, and in Maryland, all buildings must be over 500,000 square feet. In New Jersey, schools and voluntary applications, Arizona, Missouri, and Wisconsin. Now, the lead government applications are also in Austin, Texas, Boulder, Colorado, Los Angeles, California, San Diego, California, San Mateo, California, Arlington, Virginia, Cook County, Illinois, which is basically Chicago, Portland, Oregon, Seattle, Washington, San Jose, California. And the incentives: sell back the energy to a utility company, get tax breaks for all new technologies, you get rebates, grants, and loans. And here are the sources. You can look those up for yourself. Again, this has been an overview on sustainable construction. And basically, as we go back, why does it matter? Elements of sustainable buildings and the government applications. And go back and look at the environmental impact and why does it matter for all U.S. commercial building facts. Have it listed right here. You can find that at www.usgbc, which I believe it's greenbuildingcommission.org. So what I presented to you tonight talked about sustainable construction. Gave you a brief overview on what it is and why we need green building construction and how green is good for energy efficiency. That concludes this topic on sustainable construction. If you like what I just presented, just comment, share, and subscribe. And if you're looking for some political content, some scam content, you can check out my main channel, the 411 Talk Zone radio show channel. Now, something different now. When I record all of my videos, I put a 411 Talk Zone radio show channel. After I record my videos for that channel, my main channel, of course, I uploaded to YouTube. Then I also uploaded the 411 Talk Zone radio show to Twitter. Now I am on Rumble and Truth Social. Now, on the QCIS channel, since it's more of an educational channel, I upload the videos to my Twitter page and to my LinkedIn page. Once again, just want you to know that this is a learning environment. You come to the right channel because I'm giving you all kinds of information with regarding to STEM, and it's not all construction related. I know a number of videos are because I am in the construction field. Also going to be talking about sustainable materials like a bamboo, like a harvest wood, and going to get into some sustainable development as well, because it is very important that you understand what LEED is, what you understand what Energy Star is. There are a number of these certifications out there, but one thing about the field of sustainability, it is constantly growing and is part of environmental engineering. But bottom line, we want a clean environment. Again, thank you for viewing this content right here from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. You all have a wonderful, gracious evening.